Good morning. My name is Navjot Singh Gill. I am an application engineer with LI PLM Solutions. I want to welcome you to LI PLM Lunch Bytes series. So starting off with the simplified ports. Now I have this assemblies, and in this assembly, as you can see, I've used motor port, multiple subassembly levels port. So for that, what I would do is I would add it in place into this port first, and then inside my tools, there's a tab here that says Simplify. So these are the different environments which you can toggle. So in this case, I want to make a simplified port, so I have to toggle to simplify. Now one thing you will note here, when I toggle this, nothing really changed. It didn't give me any command bar, so I'm not very sure which command I have to use. But if I toggle the display to Home tab, you'll see that all these commands are activated, so I can use all of them. So first of all, we'll remove some of the faces and features. So we can use this inside this modify group. There are a bunch of commands. So first what I want to do is remove some of the rounds. So I can select the round command, and just by window selecting on the port, I can select all the rounds. The next thing which I'm going to do is delete some of the holes. So what I'm doing is I'm hiding some of the features inside my simplified version of a port. So I just select the hole command, and then I can just window select, and all the holes, they got selected. Now here's a small tip. So if you want to deselect something, what you can do is press your control key, and you can just by clicking on the selected feature or face, you can deselect that. So make sure you have control key pressed when you clicked on that highlighted face. So by doing that, I just took care of all the holes. All of them are gone. Now you will notice I have a bunch of ribs on my motor. And if I use all these commands, it will take a lot of time to prepare a simplified geometry. So I have to manually pick all the faces, manually pick all the features. So what I can do is, in order to take care of this problem, I can also add feature to it. By that I mean, with the help of extrude command, I can just create a cover on top of that feature, and that way my simplified version has a top cover, and it will hide all the features. So here I'm looking for that point to define the extent, and you'll see that in no time I took care of that problem, or else I would have spent time deleting each and every feature. So this is your simplified version of the port, and for some reason, if you are thinking, how can I get my ordered or design port, it's a very easy switch here. You can switch back to order, and it will show you your design body, and if you want to switch to simplify, it will show you simplify body. So I've done all my simplification. I can go back to the top level, and you'll notice that top level by default it shows the design port. So what I can do is, in order to show a simplified port, all I have to do is just right click on the port, and I can use this command called use simplified version of the port. So you'll see that for display purposes I can use this great tool. So the reason why I use this port in multiple subassembly level is you can hide and show simplified and design versions on different subassembly levels. That's what I want to demonstrate. For example, if I want to use a simplified version in this subassembly, I can just right click and then and tell Solid Edge to use a simplified port on that subassembly. So you can mix and match. Now, the next part we'll talk about simplified assemblies. Now when we're talking about simplified assemblies, we are dealing with ports. So with the help of simplified assembly command, you hide all the different ports in the simplification process. The same way we hide all the features and faces in simplified ports, here we're dealing with ports when we talk about simplified assemblies. So now for that, again, the steps are very similar. I switch back to tools, and then I highlight the simplify option. And there's a small tab, and this tab is only available in simplified assembly, not in port. So if you click on this option, you'll see that entire assembly, it turns green. So what does that mean? So Solid Edge is preparing geometry for simplification process. I can just hit process. And now the next step, I have to select ports which I want to exclude in this subassembly. Now, it's very similar to that slider bar where you start from the small component. So if I go this way, it's going to start from the small component. So I'm going to give you a small tip. Now, if there's a drop down here, now if you want to simplify by picking up the biggest part in the assembly, in this drop down, if you go down, it's going to start from the larger parts. So you can use this option in order to exclude parts. So in this case, what I'm going to do is like just move this letter up, and also I can graphically select parts which I want to exclude. In this case, I'm going to select all this pipes and fittings. So why I'm doing this? Because I have to send this assembly to a fabrication shop, and he doesn't need to know all this different fittings and pipes, all the different ways which these motors are connected. So all he wants to know is just how they are assembled, so that he can punch different holes on the frames, and he can cut the frame of the specified dimensions. So all done, I can just hit preview, and that's all I need to do, and I have my simplified assembly. So if you notice the Pathfinder, you will see that there is a separate simplified assembly tab. So what it does, when I keep my cursor on this tab, you'll see the entire simplified assembly highlights. So what you can do with this command is right click and do save as. So you can save this entire assembly as one part file, or you can also save this as a parasolid 3D neutral format. And we do a lot of export, and people, they just want to send the entire cover, so they didn't want the features. What you can do is, when you're saving it as a parasolid, go to options and make sure you have this export sheets. So you don't do export solids, only export sheets, and that will take care of that issue. All right. The next topic is display configurations. So for that, what I'm going to do is just open this assembly, and this assembly already has some display configuration set up, and so all the display configuration I can view with this small drop down. It tells me all the different display configuration. Now, first thing which you'll notice here is I have some default display configurations. At times it gets very annoying when people, they're working in a group, and this assembly is coming from 5 or 10 users. Then you will see that Solid Edge creates each default configuration for each different user. So if it's coming from 10 different users, it will create default configuration for 10 different users. So if you don't want that, in ST3 what they've done is they've added a new command here in the options. So if you click on configuration options, you can check this tab here for single display configuration, default configuration, so that it doesn't create different default configurations as per users. So you will have only one display configuration. Now, in order to activate display configuration, all we'll do is just select this, select the display configuration, hit OK, and that will activate display configuration. Now, the other thing which you will note here is you can activate two different display configurations. So it is going to make a union set of these two different display. If I hit OK, you'll see that it will have common components between these two different display configurations. So you can use that if you want to. Now, the other thing which you will note here is inside configuration options, there are a bunch of options all for exploded views, how this exploded display configurations are viewed in the assembly. So now, all these settings by default, when you load Solid Edge, you will see that you get this middle setting that says apply display setting only, and this is related to exploded configurations. So I have exploded configuration here. So what I'm going to do is select this exploded configuration, hit OK. You'll see that I didn't get my exploded view. Right? So if you're wondering which is the best setting for this type of purpose, now you can change the display, apply display setting only to this switch to ERA and explode. So what that will do is, once you have that setting, hit OK, it will automatically switch the display to ERA, that is explode, render, animate, and also it will create the explosion for you, the explosion which you saved in the display configuration. So there's another setting which you can turn on, and that is like just prompt for action. So what it's going to do is once you select that setting, hit OK, it is going to ask you whether you want to change to ERA or not. So if you say yes, it's going to change ERA and show you your display configuration, your manual display configuration or automatic display configuration, exploded view. All right. So now I can switch back to the default, like say fan, close out of the exploded view. Now one more thing which is, I think, very important here is this application overrides. So what are these overrides? So now what you will see is whenever I'm changing a display configuration and hit OK, you'll see that all the parts inside these subassemblies, they are inactive. So this is because of this option which modify the port to as an inactivated port. So if you want all of them to be activated, all you have to do is just hit OK. Now when I change the display, it is going to list all the different ports as activated port. So by doing this, you can improve the performance, create an inactivate all the ports, and then if you change the display, it is going to inactivate all the ports. So it's not loading all the maths behind the port on your physical memory. So you can save your physical memory this way. Now, the next thing is they've added is this tab, small tab here, fit view after apply. What does that do? Now, if I change this display and like change the zoom configuration here, like I can just zoom in, zoom out. Now, at this point, if I change the configuration, like say for example, this one, you'll notice that based on your zoom setting, it hides, unhides, it activates, inactivates the port. Maybe this is what you want, maybe not. If you're working in a huge assembly, you won't be able to find the exact part or assembly or subassembly. So what you can do is, there's a small tab here that says fit view after apply. They've added this in ST3. What you can do is, if you check this option and then you change it, you'll notice that it applies the configuration and also automatically fits that configuration to your screen. So you don't have to click on fit to screens after applying your display configuration. So it's all automated now. All right. So the next option is here that says unload hidden parts. So what it does, it whatever parts you have not shown, like I'm not showing up here, you can hide, you can unload that from the physical memory with the help of this unload hidden parts command. All right, there's another option here. Let me go back to the default option configuration. So what I'm going to do is I'll create a new snapshot. So what is this snapshot? They have added this command called take snapshot. So what you can do is, it's just like you can hide, unhide different parts. Like for example, say no, I want to display that one, and I can uncheck all these. All right. So what you can do is you can have one snapshot per assembly file. So if I hit take snapshot command, you'll see that it automatically generates a snapshot configuration. So you can toggle, like if you are in a different configuration, you can always restore the snapshot. So these two tabs are added in ST3, like take snapshot and restore snapshot. Right. Now let me open another assembly to show you some more options in display configuration, which they have introduced in ST3. And let me find, okay, all right. You'll notice here they've added this new tab called Configuration Manager. So if you click on this tab, it gives you a tabular format where you can hide, unhide different parts in different configurations. So on the top, you'll see these columns. These all are my display configurations. And there's a column for a new component. So by this, what they're giving user the facility to once he have added new component, he can choose a component in different assembly display configurations. So for that, what I'm going to do is add a new component first, and then I'll show you how you can add that component to the display configuration. So I'll just bring this part in. I have a small tip. Now, since I've dragged this part and maybe this is not the right location, what you can do is if you press Shift on your keyboard and then you can move the part. You can bring that closer. And also if you press Control, you can rotate the part. Now you can also use your quick pick. Maybe if you are looking for a specific purpose, you can use this command. It's very handy. Now, you'll see that when I'm moving or rotating the part, there's one face automatically gets selected, and I don't want to use this face in my assemble process. So in order to deselect, all I have to do is just right-click, and now I can select the face for mating. This one with this, and also I can do an eggshell align. Since I have a flash fit, so I don't have to select the eggshell align command. So all I can do is just select this hole and then assemble it down here. Alright, so we just added new component. Let's go back to the configuration manager and see. Alright, so what it's telling me is there's a new component that has been added to this top level assembly, and this component can be a subassembly with different parts. In that case, you will see this check mark on all the different parts or different subassemblies. Now it gives me an option where I want to save, like on which display configuration I want to show this part. So for example, I want to show up in this. So what I will do is select this display configuration so that this part will appear only in this missing head display configuration. So don't forget to hit save. And now what I can do is I can just select the missing head configuration, and you'll see that now that configuration has this new component. Right? So that's how you can add the component. So this tabular form, what you can do is it gives you more flexibility. Like I can deselect any part from any subassembly, and all I have to do is just hit save, and that will save inside the display configuration file that's created. At the bottom left corner, you can browse it. One thing I would like to mention here is whenever you see this configuration.cfg file, that's one of the main reasons why I ask people to use Revision Manager whenever they are copying assembly file from one location to another. So even though you will think that this is not linked, but Revision Manager takes care. It doesn't list in the tabular form, but it will move this configuration file from one location to another when you use a Revision Manager to copy your documents. So again, that's very important. All right. The next thing which I'm going to show you is about Interpod Copy and how you can use that command. All right. So whenever I open a new template, you'll see by default I get a synchronous mode. I can always change that just by clicking on Transition to Order. Now, the reason why I did this transition was because this Interpod Copy command works a little different in these two environments, and I'm going to address that. Now, what you can do is if you are at Home tab, on the left-hand corner there is a small tab for Port Copy. So you can select this tab, even though it says Port Copy, but you can always select assemblies. So it gives you ability to bring assembly inside a port environment. So now here what I'm going to do is select this part, and now this is a pipe cross section. I'm going to open that inside. And it opens up a nice dialog box. And there's a lot of functionality built inside this dialog box. Now, the first main difference between ordered and synchronous is you will not have this link to file option if you are inside synchronous environment. So what does that mean? So if tomorrow, if I change this part in the original format, it will not update this new part. So it's not linked. There won't be a link. So this tab will be missing in synchronous. So now it also takes care of, there are some options here. So what you can do is, since it's linked, it gives you option whether you want to update automatically or you want a prompt that should tell you that whether you want to update or not if you have some changes on the parent body. Now, one important thing which I'm going to show you is difference between these two options, design body and construction body, and how we can use this in this command. So right now for that, what I'm going to do is just put a small clipping plane. So all I have to do is just select the face and put this plane. Right now it says this solid. So if I want this as a construction surface, what I can do is I can go to edit definition, and inside options I can change this to construction body. So what, and hit apply, and you'll see that now it's just a hollow body. So this will answer the question when people want just the outer surface of a part. They don't want to give the entire intelligence inside the model, like a design body. So you can use this command on your assemblies. You can use this command on your part. Bring that part in, assembly in with this construction body option, and you'll have an outer cover. All right. So I'll just bring this as a construction body, and I don't want this clipping plane now. I can turn that off. The reason why I want to bring that as a construction body in this scenario is I want to create a female member, like a mold, out of this part. So what I can do is I can just create a small extrusion on the end, on any end of this part. Like say here, I'll give it a diameter of 100, and then I can give it an extent. Now here, as I'm moving towards left, I can use my quick pick to pick the extent, and now you'll see that it covers my parent body. So what I can do is, since that's a surface, I can use my surfacing tool to delete that body. So if I toggle back to surfacing, inside the replace face command, there is a command called Boolean. It gives you three options: unite, subtract, and find the intersection. So these are the three. By default it says subtraction. That's what I want. So what I can do is select this internal face, and I can just subtract that body, and in no time I got my mold from my finished product. Alright, I forgot to tell you one option. So that option was inside this part copy. Now if you have a plastic part, you would always like to have a shrink factor inside this. So what you can do is use the scaling option, and you can scale that part to like 1.2 or whatever you want. All this information, the company which is supplying you material can give you a shrinkage factor. You can enter that factor here and bring that final product inside your part. Again, very helpful. Now, you can also use the same workflow if you want to scale your part bigger or smaller. So you can use this, like if you want to make it half or 2 times, you can put a scale, hit OK, apply, and that will make your part bigger or smaller depending upon the scale. So that's one workflow where you can use this part copy command. The next option which I'm going to show you is Interpod Copy. And please forgive me if I'm using a little bit more time. I have a lot of stuff to present. Please excuse. Now, in this case, what I would do is select this assembly. Now, what I will do is I will, in this case, I don't want all the different parts, so I'll just hide some of the parts, just to improve the visual. Now here you'll notice I have a motor, and maybe this is a motor which I download from a customer's website stuff like that. And I'm modeling this flange. And you will notice here that the end of the flange is very much different. The end of the motor flange is very different than what I have on my model flange. So what I can do is I will use the Interpod Copy command in order to take care of that issue. So for that, I'll just add it in place into my port. What I can do is in the same dialog box where we used port copy previously, there's an option here called Interpod Copy. I can select that command, select the port, and now I can select this face. This is the end face which I want. So I can just copy this. I don't want any associativity. I can break this. And just by grabbing the face, I can use steering wheel to move that face onto the surface of this flange. Alright. So now what I want to do is I want to select this surface and the surface which I copied, and what I can tell Solid Edge is to create extrusion. So with extrusion I can define the extent, and I don't need to enter any distance, so I just grab the end of the face. Alright, let me select this one more time. Okay. Sky, extrude. Alright, here you go. Alright, I don't need that copied surface, so what I would do is I would delete the surface which I just copied, so I can just right click this surface and delete it. So that will take care of that. I also want to extend this this flange, so what I'll do is just go to the top view, and now what I can do is just window select the flange, and with the help of my steering wheel I can just select the endpoint here, and that will take care of the mating. And you'll notice here with no time I was able to modify the flange, and based on the requirement. Now I can just show all of the part, and you'll see that everything looks good and these two flanges are meshed. So that's one example where you can use this Interpod Copy command. This command is more specific to assembly environment where you want to use some of the geometry of your background parts. Alright, that's all I have as far as the presentation part is concerned. I'm going to address some of the commands like inactivate, what that does. When you inactivate a component, you can get a display of the component, but what it does, it unloads the part from the memory. So that improves the display performance and also uses less physical memory. The other option is what happens when you hide the component. This option, it makes your display less clutter. You can hide different parts inside assembly, and it also help you work more efficiently by selecting parts quickly. Now hiding components also reduce the physical memory demand, which improves performance. Again, you can use hide component, inactivate, and this option, again very important, is unloading components. So what you can do with this command is all your hidden components, with this command you can unload those components from your physical memory. So if you are having some performance with memory, then this command is you can use this command to get better performance. Alright, the replays of this session, they're available on our channel, YouTube channel, and also there's some trainings coming up next month, fundamentals update, and also all the training details are on our website. Again, thank you very much for your time today. If you have any questions, comments, please email us, call us. Here's our contact information. Again, thank you very much for your time.